Bismillahirrahmanirrahim. Sallallahu alayhi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa sallam. Ameen. Alhamdulillahi rabbil alameen. We should be serious. If we are serious, then we can do everything with good concentration. And good concentration is the key to success. The binomial distribution, lecture 1. Discrete distributions. Two special discrete distributions, the binomial distribution and geometric distribution. The word discrete means countable quantities, like number of students in a class, number of chairs in a room, number of fans in a hall. A binomial distribution can be used to model the number of success in a fixed number of independent trials, where the probability of success in each trial is constant. Whereas a geometric distribution can be modeled the number of trials up to and including the first success in an infinite number of independent trials, where the probability of success in each trial is constant. The different thing between geometric and binomial is, in binomial we have fixed number of trials, the trials are fixed in number, constant number of trials, and in geometric the trials are infinite, because we in geometric we repeat the process until we get the requirement, until we get the success. Now let's start with binomial distribution. In this lecture I will discuss binomial distribution only. I will discuss geometric distribution in my next lecture, inshallah. A discrete random variable that meets the following criteria is said to have a binomial distribution, and it is defined by its two parameters n and p. N and p are the parameters of this distribution. Parameters means quantities which define the distribution. Now these are four conditions for binomial model. There are n repeated independent trials. The trials must be independent. N must be fixed. And it should be finite, like 30, 40, 20. There are just two possible outcomes. This is the next condition, just two possible outcomes for each trial. That is success or failure. Binomial means two, so there must be only two outcomes for each trial. The probability of success in each trial, P, must be constant. So there should be n independent trials. The value of n must be fixed. There must be just two possible outcomes for each trial, and the probability of success must be constant. The random variable is the number of trials that result in a success. A discrete random variable x. A discrete random variable x. X is discrete, and I already have told you discrete means countable quantities. That has a binomial distribution is denoted by. This is the way we describe the distribution. X follows binomial with parameters n and p. Sorry. The probability of x successes in n trials is this. This is the formula of finding the x successes in n fixed trials is this. Probability x is equal to small x, nc small x, p is small, x is small, q n power minus x, q to the power n minus x. So we use this formula to find the probabilities of the requirement in binomial distribution, where x starts from 0. X in fact is whole number, 0 to n. Since x represents the number of successes, so it can take integer values from 0 to n, and n is positive integer. So n takes positive integer values only. The values of n start from 1. Since we have this formula for the probability of binomial, Then, therefore, for x0, if we substitute x0, we'll get q power n. And 0 means none. I have mentioned this here. Sorry. And when we substitute x is n means all, then we'll get p power n. So these two rules will make the calculations very simple. 0 means none and n means all. Examples for binomial distribution model. For example, score 5 and 5 complement on a fair die. This is an example of binomial model because there are two outcomes and probabilities of each outcome is constant. The probability of 5 on a fair die is 1 upon 6 and not 5 is 5 upon 6. And every trial is independent. There are independent trials. Now, the next example is broken and unbroken biscuits in a packet of 20. So the probability must be fixed. And there are two outcomes. A and A complement is one of the best examples for binomial distribution. See, A means let's suppose success and Q means failures. Therefore, the total of these two, the sum of these two probabilities must be 1. Therefore, Q must be 1 minus P. Binomial distribution is for countable quantities like number of students in a class and like this. The mean of binomial distribution. This is the formula of mean of binomial. It's NP. And the variance of binomial distribution is NPQ. Now, rules to make the calculation simple. Now, these rules are very important. Sorry. I already have discussed this rule number 1 and 2. According to rule 1, n means all. When you are finding probability for all, the answer will be p power n. And 0 means none. Therefore, the answer will be q power n. Now, rule number 3 is very important. At least one. Now, this is the direct method. Now, there are two methods. This one is the direct method. And obviously, this method will be very long. This will make your calculation very lengthy, and this will waste your time, in fact. And this is the indirect method. So since we have done these things in probability, so you will easily understand these things. Now, for at least one, you must start from 1, indirect method. Like your number could be 1, either 1 or 2 or 3 or 2 to the last value, which is n. And since this method is very lengthy, therefore you have to use the indirect method. And according to indirect method, this at least one will be 1 minus P0. We write the number 0 here because 0 is not in this list. So in indirect method, we take the numbers here which are not in this list, which are not in the list of direct method. So make sure you write the numbers here carefully. Since 0 is not there in the direct method, therefore I wrote 1 minus P0. Sorry. Now, for probability x greater equal to 2, obviously you will start from 2, but this method is lengthy, so you will have to use the indirect method. Now, according to direct method, the numbers 0 or 1 are not in this list, in the list of direct method. So, when you will use indirect method, you should use 1 minus P01. Write those numbers here which are not in the list of direct method. And be careful, you must not make mistake here. If you will mistake here, you will lose a lot of marks. Be careful while using these methods. Now, greater than 2, this is very important. And normally students do mistakes here. They wrongly skip 2 here because they don't list the numbers for direct method. So the best way is, in order to avoid the mistakes and careless mistakes, you must write the numbers for direct method first. I mean, if you will use this way, I mean, if you will write the numbers of direct method, then you will not make mistake while using this indirect method, inshallah. So according to direct method, the list will start from 3 because this 2 is exclusive. So this list is starting from 3. Therefore, 3 numbers are not in this list, which are 0, 1 or 2. So you just need to write 1 minus p 0, 1 and 2 here. So this is the safe way for the calculation and using the indirect method. In rule 3 and 4, for 1 minus probability, take those values of x which are not in probability x greater or equal to 1. That is x0 and x01. I already have explained these things in detail while explaining the rules. Well, this is very simple and you have to use this method only. For x less than or equal to 2, you just need to list the required numbers 2, 1, 0. For less than 2, make sure you must not write 2 here. The numbers will be 1 or 0 because 2 is not inclusive here. It is basically exclusive. So when the number is exclusive, don't take that number. X greater or equal to 8. If n is 9, then use direct method, 8 or 9. I mean, no need to use indirect method here because this is the shortest way. So these are the rules which will make your calculation very simple. Make sure you understand these rules and you practice a lot of these rules so that you will avoid the careless mistakes during your exam and test. So we have discussed the rules to make the calculation simple, and the hint is always write the always list the numbers of direct method. First, and then list the numbers for indirect method. So this is the way to avoid careless mistakes. Must list the numbers for direct method first, and then with the help of those numbers you can list the numbers of indirect method. I mean, avoid the shortcuts. If you will avoid shortcuts, you will be able to eliminate the careless mistakes, and you will be able to avoid the careless mistakes, hopefully. Now this is a new situation, a new thing, a very important thing in binomial distribution. This is basically the P of binomial from the previous parts. Here we have some cases, like this is case number 1. Sometimes we have two binomial models and we find P from the previous binomial model for the new or following binomial model. An example of this is June 12, paper 61, and in my worksheet it's 9 part 2. Now let's discuss this thing. I'm sorry. Question 9 part 2. Now this question's part 2. For 4 randomly chosen 7-day periods in winter, find the probability that exactly 3 of these periods will have at least one day with more than 20 centimeters of snow falling. Now the requirement is This is the requirement. For 4 randomly chosen periods. 3, exactly 3 from 4 periods. This is the second model. Now, this thing is very important. Will have at least one day with more than 20 centimeters snowfall. Now, this is the information which we will use to get the P for this new model. See, the information is at least one day with more than 20 centimeters of snow falling. Now, this is the model 2. Make sure you understand this thing carefully and well. Now, this is model 2. So, according to this model, basically we need this probability 4C3, 3 here, and this must be 1. And we write P here. And this is very simple, this is Q. So, how will we find P for this calculation? Now, for P of this calculation, we have to use this information. And this is model 1. Now, it's mentioned in the first line that the probability more than 20 centimeters snow falling on any particular day is 0.21. Now, for this model, P is 0.21. And we need at least one day. So we just need to calculate this probability. So at least 1 is calculated like this. This is the way to calculate at least 1. So it will be 1 minus q to the power n. And in the first question, there were 7 periods. And it's mentioned here as well 7 a day. So 7, and this 7 is for model 1. And P is 0.21, and here we write Q basically, so it should be, I guess, 79. Therefore, this answer is 0.808. This is not the right way to write this answer. This must be up to 4 decimal places. So make sure you write 4 decimal places value here. And now use this value here, 0.808, and this will be 1 minus P, which is 0.192. So this is the way to get P for the new binomial model from the previous binomial model. Let me repeat this question because this question is very important, so I would like to repeat this. The question is, for 4 randomly chosen 7-day periods in winter, find the probability that exactly 3 of these periods will have at least one day with more than 20 centimeters of snow falling. Now, how to solve this question easily? Now, this is the best way to solve this question easily. First, write the information in the bracket. If you will write the information in the bracket, you will be able to solve this question easily. X3 from 4 periods, this is here. At least one day with more than 20 centimeters of snow falling, this information is here, and this information is in fact for the calculation of P. So at least 1 can be written as 1 minus P0, 1 minus Q to the power n. Now how will you get P and Q? This information will give you P. Now this is P, and this information is basically from part 1. So this is the way to get the P for the next part, for this part, for the next binomial model. And after getting this P, substitute P here and Q here. So this is the way to solve questions of these types. Now, case 2. Sorry. P through the conditional probability. Now, in like very sometimes you can say in few questions they give this information as well. In the previous case, we found P from the previous binomial model. There were two binomial model in fact. Now in this case, there is a binomial model, but in the previous part there is just probability, and with the help of that probability and conditional probability we find P. And the example of this question is question 8, and in past paper it's November 11 paper 62. Now let me discuss this question. This here is question 8. Now there are large number of students in L college. I'm not reading this information, you can go through this information later. I'm more interested in part 2, and this part 2 is basically binomial model. Sorry. Now what is the difference between part 1 and part 2? Okay, let's discuss part 1 first. 6 boys, now this is very important. 6 boys. Now boys are very important in this question. 6 boys are chosen at random. Find the probability that fewer than 3 of them choose music. Now this situation is very simple. There are 6 boys, n is 6, and the boys who choose music is 0.15. So the question is very simple. You just need fewer than 3, and this is the way to get fewer than 3. The required numbers will be 0, 1 or 2. Now what's the difference between part 1 and part 2? Now in part 2, there is this thing, students. Now this is the difference between part 1 and part 2. Because in part 1 they differentiated the students. There were 6 boys. In part 2 they did not differentiate the students like boys or girls. So students means either boys or girls, or in fact both. So 5 drama students are chosen at random. This is the conditional probability. When there is no differentiation, when there is a general term, then you have to use conditional probability. So I'm reading this question as, given that 5 drama students are chosen at random. Hopefully you have understood this with the help of these two words, given that, because they usually use given that for conditional probability. But this is a very unique question. Here these students, this word students means conditional probability. So given that 5 drama students are chosen at random, find the probability that at least one of them is a boy. Now first write this information here. If you want to solve this question easily, then write the information in this way. At least one of them is a boy, and 5 is basically n. And here conditional probability. Boys who choose drama. Now this information will help you to get P. So this P is basically conditional probability. I'm writing this here as probability B drama. Boys who participate in drama is 0.06, and the probability for drama is 0.28. So P will be 0.2143. I'm leaving the calculation of conditional probability. You know how to find a conditional probability. For that you should use tree diagram. I'm making tree diagram, drawing tree diagram here for all of you. There were 0.4% girls, 0.6%, 0.4 probability for girls, and 0.6 for probability for boys. And there are 3 things. This tree is not required, so I'm just using for this tree for drama. Now, boys who participate in drama is 0.1 probability and girls has 0.55. You know, this thing must be in denominator. So this is the way to get the conditional probability easily. And I use those that creed for this calculation. Now you just need to substitute this p here. Now you know at least one is 1 minus q power n. So q will be 0.7857. Make sure you use 4 decimal place value here. And your final answer is 0.701. Now this is the way to solve questions of this type. Get p from the conditional probability and then you can get the answer of this part. So this was case 2. Now the next case. I'm sorry. P through the normal distribution. There are a lot of questions of this type, but I'm just mentioning one question, question 21, June 15, paper 63. But right now, I won't be able to discuss this concept because you haven't done normal distribution. Once you will do normal distribution, then I will discuss this thing in my next lecture, inshallah. That will be binomial distribution lecture 1 part 2. And I have mentioned this here. This will be done after the completion of the normal distribution. So I'm leaving this here. Now, expected profit. This is a new concept in binomial. There is just one question of this type, 11 part 2, and in past paper it's November 12, paper 61, and I have made this formula to solve a question of this type, expected net profit. So the formula for expected net profit is gross profit minus expenses, and the formula of gross profit is selling price into profit percent minus cost. So with the help of this formula, you can easily solve that question. Let me show you the question here. It's question 11, part 2. Here is the question. So just reading part 2. The 20 fireworks cost the company 24. So with the help of this 20 and 24, you can get the cost. So the cost will be 20 times 24, which will make 480. Now 450 people pay the company $10. Now this will give you selling price. So I'm just writing here. Cost will be 20 into 24, which will make 480. And selling price, or you can just say, yeah, it's selling price. I think that this term is better. Will be 450 into 10. This will be $4,500. If more than one firework fails to work, they get their money back. Now, what is the probability of failing the fireworks? It's here in part 1. And this answer is, let me check the answer of part 1 here. It's 26.4%. So the probability of loss, or exactly loss, is 26.4%. This is the probability for loss. So probability for profit will be, let me check, what is the probability? It's 73.6%. In decimal, it should be 736. Now the question is, calculate the expected net profit, expected profit. And I already have told you this formula. The formula is here. The expected net profit. I'm doing this calculation here. Expected net profit will be gross profit, which is selling price, into profit percent, which is 0.736, minus cost, which is 480, and your answer will be 2832. This is the expected net profit. I have used that formula which I already have told you in my notes. So here is the whole question. Same concept is used here, but I tried to make the calculation simple. First get the cost, then get the selling price, and then get the profit, and then use this formula, and we will get the answer. All right, we have done this concept. Now the next concept is the highest probability observation. This value is one of the two values closest to the mean of x. Now this is the way to get the highest probability observation. We first find mean and then we check the value of mean. So if the mean is 8.4, let's suppose, even then we check the probability of the observations 8 and 9. I mean, we will not basically round off the number 8.4 to 8. The observation is 8. This is not right. You just need to calculate the probabilities of both the numbers 8 and 9, and then you will get the highest probability observation. So if probability of 8 is 0.201 and probability of number 9 is 0.203, so obviously the highest probability is of observation 9. Therefore x is equal to 9 is the observation which has the highest probability. So this is the way to get the highest probability observation, and the example of this question is 7 part 2 June 11 paper 63. Okay, let me show you that question. Question 7. Yeah, here, it's here. So what is question number 7? Question 7 is part 2. Sue attempts 14 Sudoku puzzles every month. The number that she completes successfully is denoted by x. Find the value of x. Now this is the question that has the highest probability. You may assume that this value is one of the two closest values to the mean of x, in fact. So we will first work for mean. The mean is 10.5. So we will check the probability of 10 and 11. The probability of 10 is 0.22 in fact, and this is 0.24. Obviously this probability is highest, therefore this is the required observation. What if we had 10.4? Again we had to check both the numbers 10 and 11. So never round off the number. Whenever you get fractional value, always check the probability of both the numbers. So this is the best way to get the required value of x, which has the highest probability. Now the next concept is the greatest number of objects. Now this is the formula of getting the greatest number of objects. Obviously it must be n. I mean the greatest number of objects must be n, and the example of this concept is 19 part 1, and in past paper it's November 14 paper 63. So 19 part 1. Let me discuss 19 part 1 with all of you. This is 19 part 1, and I will just discuss part 1 only because this is the required part. The number of books read by members of a book club each year has the binomial distribution. Now the value of n is 12. Now state the greatest number of books that could be read by a member of the book club in a particular year and find the probability that a member reads this number of books. So greatest number of books. Obviously the value of n is 12, therefore the greatest number of books must be 12. X greatest must be n, which is 12. And you can easily get the probability of this number 12. So this was the concept. Now, I tried my level best to discuss all the concepts of binomial distribution in this lecture. I hope this lecture will help you all a lot, inshallah. And make sure you must watch this lecture carefully. If you want to get something, you must pay attention. You must be attentive. You must be. You must pay attention during the lecture, during the lesson, and do everything with good concentration. And the most important thing is focus on the time management. Inshallah, I will discuss geometric distribution and probability distribution in my next lectures. Allah Hafiz.